Hi everyone, welcome back. So today's topic is going to be on creating a singly linked list, okay, in C programming. So let me first tell you what I'm going to do, how many nodes I'll be creating in a singly linked list. So I'm going to teach you creating 3 nodes, okay, in singly linked list. How the nodes exactly will look is, there are 3 nodes with 2 paths inside that, okay. I'm just showing you the output, how exactly a singly linked list will look with 3 different nodes. Okay, so you have 2 parts, one is the data part and the link part. Again, in the second node, you have data part and link part. The third node also has the same data part and the link part, and the values will be 10, data values 20 and 30. The link will have link to the next node, and this link will have link to the next node. And the third one, since it's not pointing to any node, this will be null. Assume, for example, if this node is at address 1000, this node has been created at address 2000, this one at 3000. Then the first node pointing to link will be the address. So it is address 2000. This is pointing to the node of address at address 3000. So it will be pointing to this 3000. So this is how the final output will look after creating a node in singly linked list. 3 different nodes in singly linked list. So let me move on to the concept, how to create a singly linked list. So for instance, I'm just taking for 3 different nodes. Fine. Okay, now moving on to the actual concept. In order to create each node, in my previous video you would have seen about self-referential structures. So when a structure has a pointer that points to the same structure, then it is called as self-referential structure, just like recursive function. A recursive function, it calls the same function again and again within itself, then it is called as recursive function. In the same way, when a structure variable has a pointer, when a structure has a pointer that is pointing to itself, then it is called as self-referential structure. So in order to create any node, I need to have a self-referential structure. So how do we declare a self-referential structure? Using structure. So the keyword struct node is a name. You can give any name here. Since I'm creating singly linked list, I need to create node. I'm giving the structure name as node. Struct node. I'm just, for the simplicity purpose, I'll be taking only one data value. You can have multiple data values of different data type. Okay, so int data is one member variable followed by struct node star link and semicolon. This is the syntax for structure. See here, there are two datas. One is the integer data, the other one is struct node star link. Link is a pointer which points to the same structure. So this is a self-referential structure. Okay, so the header files that will be supported will be #include stdio.h and #include stdlib.h. stdlib.h actually stands, it's mainly used to which supports the dynamic memory allocation functions like malloc, calloc, realloc and free. So I'll be using stdlib.h here. 2 functions. For the first function for standard input output statements, the second one is for dynamic memory allocation. Fine. Now after declaring the structure, how will the node look? I mean, I've not created the node, but how will the structure look actually? So the first structure will be 2 parts, data part and link part. So this is the actual, after declaring, this will be the actual output. Fine. But in order to, not only declaring, in order to allocate memory, I need to make use of malloc function, so that memory space is being allocated. Fine. So now within main function, int main, fine, I need to allocate memory, so I need to make use of pointers. See the previous video of dynamic memory allocation malloc function, you will understand. So we need to have a pointer variable which points, that is self-referential pointer, so that we can directly access the data value as well as the link part, data part and link part. So what should I do? Struct node star head. So initially I'll have a head pointer, so where this head pointer should be pointing to the first node after creating. So we need to create a node. This is only declaration part of the structure. We need to create a node. How do you create a node? Head is equal to malloc of size of struct space node. See here, malloc size of struct space node. Size of, for which one I'm trying to allocate, dynamically allocate memory for the structure node. What is structure node? It will allocate memory space for both the member variables, that is the data variable and the pointer variable. So using malloc. Okay, now after successfully allocating the memory space, it will return a void pointer. Malloc will return a void pointer, and the first byte will be pointed by the header variable. It's a pointer variable. It's a pointer variable of the same structure. Okay, so now what will happen after creating? Head will be pointed to this particular node. So after memory allocation means address will be assigned. Memory has been allocated for this node. So assume if this particular node has been allocated starting at address 1000. So head is pointing to 1000. After this particular line, we will have head with no value. But after the second line, head will be assigned with the first byte of the memory allocated to this particular node. So it is nothing but 1000. So head will have the value 1000, which means head is pointing to the first node that is created. So it is called as the head node. Understood? The first node which is created is called as the head node. Fine. Okay, now we have to add data. We have to add data inside the head node where it has one data part. So I need to declare a value that holds an integer value. Okay, a value that holds integer. So I'm just naming the variable as value. Now let me ask the user printf enter number of nodes. Enter number of nodes. So scanf %d address of, let me write number of nodes. For the simplicity purpose, I've given number of nodes as 3 when I'm tracing the code. So in general, it will be number of nodes n. So I have to declare variable n also here. Fine. So in the memory, what will happen when n is declared there? N value, suppose if I'm assuming that I'll give n value will be 3. So now n value is equal to 3. Okay. Now first I've created the first node called as the head node. Now let me add values to the first node. So printf enter value of first node. Okay, so scanf %d address of value. Let me put the value that is read from the user in the variable value. So value is again declared after this line. What is the value? Assume that I'm entering 10. I'm entering value 10. Now value has 10. The variable value will have 10 in the memory. Now I have to copy this value, variable value, into data. How do I do that? Using arrow operator. Head is pointing to the first node. So using head operator, arrow operator, head pointing to data. Since I'm adding value to data, head pointing to data is equal to value. So what exactly is happening? The value, the content within the value is stored in head pointing to data. So after this line, what happens? The value 10 is stored in the node. Understood? Clear? Okay, now what is head pointing to link? Since it is a pointer variable, the value within the link should be an address. Okay, so initially head pointing to link is equal to null. So let me put the value null here. So we have created one node using malloc, and the address, for assumption it is 1000. It is pointed by the head pointer. Fine. Then I'm asking the user to enter the number of nodes that I'm going to create. So it is number of nodes is 3. I'm going to create a node similar to this, another 2 nodes which is similar to the head node. Okay. Then I'm asking the user to enter the first value of the node, data value of the node. So I'm storing it in value variable, and finally using arrow operator I use head pointing to data is equal to value. So 10 is stored here, and then next part is the link part. The link part will always point to the, it is a pointer variable, so which holds only the address. So initially let me put the address value is equal to null. So this is how you create the first node. These 4 lines will tell you how to create the first node in linked list. Okay, now similarly, similar to this particular node, I have to create 2 more nodes, right? So how do I create now? Please understand, after this, okay, now I'll add one more pointer variable called temp. It is a temporary pointer variable. I make temp is equal to head. What is head value? Now here temp initially is empty after this line. Now what I'm doing, temp is equal to head. What is head value? 1000. So temp is also 1000, which means there's one more pointer variable called temp, which is pointing to the same head node. Now there are 2 pointers which are pointing to the head node, the head pointer as well as the temp pointer. Now why I'm using 2 different pointers is, I'm not going to make use of head pointer. I'm not going to navigate head pointer further to the other nodes, because we need to have reference to the first node. So I keep head as the main node, the first node. I'll use a temporary pointer variable so that I can navigate between the nodes. So that's why I'm using this particular sentence, temp is equal to head. So now with the help of temp, I can move between the other nodes. Okay, so that I can provide link between the other nodes from one node to another. That's why I'm using temp. Fine. Now I have to create one more node like that, similar node to the first node with the same type, data and link. So what should I do again? Struct node star head star temp star. I'll use F node, which stands for first node. This is a head node. Next one is the first node. So how do I create this particular node? We have to allocate memory. How do we allocate? In the same way, right? How did we allocate? Head is equal to malloc size of struct node, right? Similarly, what should I do? F node is equal to malloc of size of struct node. So what this happens, F node will be created and an address will be generated. Assume the address of this particular node is 2000. So F node is created with value 2000. Understood? So F node is created with value 2000. Okay, then what should we do? We have to add values, right? This is the data part and this is the link part. How did we add values here? Again, enter the value, scanf value, head pointing to data value, head pointing to link null. Similarly, what is the name of the node? It is F node. So what do we do? Printf, enter value of node, scanf, %d, address of value, the same thing. Okay, now if suppose value is 20, the value of 10 will be replaced by 20. So where should I store? The value 20 should be stored in the second node. So what should we do? What is the name of the node? F node. F node pointing to data part using arrow operator is equal to value. Then F node pointing to link is equal to null. You understood? So F node pointing to data, I'm copying the value variable content, then link is equal to null. Now just have a look. There are 2 nodes which are created separately, but there is no link provided here. We have to provide link. Okay, the same content to provide the second node. Okay, now how do we provide link? The link part should point to the second node, which means it should point to 2000. So what do? I'm not going to make use of the head pointer in order to navigate. I'll make use of the temporary pointer variable in order to provide link between the head node and the first node. So what should be the statement here? Temp pointing to link. Temp pointing to link is equal to F node. Temp pointing to link is equal to F node. What is F node value? 2000. Okay, so temp pointing to link, initially it was null, right? Temp pointing, null, head pointing to null, link is null. Temp pointing to link is also null. Now I'm changing. Temp pointing to link is equal to null, is equal to F node. So instead of null, it will be 2000, which means we are providing link between the head node and the first node. The value of this temp will be Okay, now we have temp pointing to link is equal to f node, right? Then after that, I'm trying to move this temp variable to the next node, which means the temp variable should be pointing to 2000, correct? After providing link, I'm navigating temp to the next node because I have to again link another node using the temp variable. Fine. So what should I do? I have to change temp to 2000. So what is the code here? Temp is equal to temp pointing to link. See here, temp pointing to link is equal to 2000. After changing that, I'm just navigating temp. So temp is equal to temp pointing to link, which means from here temp will move here. Now temp is pointing to this particular node. You got it? Okay, so with the help of temp, again I can combine, I can link another nodes of the similar type, structure type. Okay, so this is a code for creating the second node. Now similarly, I have to create one more node. So what should I do? When I execute this particular code once, I will be able to create another new node, that is first node, and I can provide the link. Okay, in the same fashion, when I want to create another node, I have to put the same this part of code into a loop. Okay, so what will I do? I just write for I is equal to 0 to I less than or equal to n I plus plus. I equal to 2. Why 2? Because already I have created one node. Okay, the head node. This is the head node creation. I have to move from the second node onwards. That's why for I is equal to 2, I less than or equal to n, I plus plus. Now just see the tracing part here. Trace 1 when I is equal to 2. When I is equal to 1, this is created. I is equal to 2. 2 is less than or equal to 3. N value is 3. It will enter F node. So it's creating F node. Okay, enter the value of the node. Value of the node I'm entering 20. Okay, F node pointing to data is equal to 20. F node pointing to link is equal to null. Then what do? Temp pointing to link. Temp pointing, initially temp is here. Temp pointing to link is equal to F node. So it will be replaced with 2000. Then I am moving temp pointer to the second node. Temp is equal to temp pointing to link. So the temp value will become 2000. Fine. Now after this, again I value is equal to 3. Is 3 less than or equal to 3? Yes, it's true. When it is true, it enters. So again it creates one more node. Now this becomes a new F node. Okay, then enter the value of the node. Suppose I enter value of the node as 30. Value will be changed here. I'm replacing the value here. Then what do? F node pointing to data. What is F node here? Suppose assume it is 3000 at address 3000. Okay, this the same node I can reuse to create new nodes. Now this doesn't become an F node. The new one is the F node here. Okay, now what happens? F node pointing to data is equal to value. What is data value? It is 30. Now F node pointing to link is equal to null. This is null. Then temp pointing to link is equal to F node. What is current F node value here? Instead of 2000, this has become 3000, right? Now temp node pointing to link is equal to F node. So there is a link from this particular node to this particular node because this value has been changed to 3000. Link F node. Temp pointing to link. Current temp is pointing here. Fine. Then temp is equal to temp pointing to link. So from here, temp is again moved to the next node. Then next iteration, third iteration, I is equal to 4. 4 is not less than or equal to 3. So it is false. So it comes out. So this is how it creates. So the last pointer will always be null, which means it is not pointing to another node. So I have created 3 different nodes with 10, 20 and 30. Understood? Clear? Okay, now after this, I need to display the values, right? We need to display. How do I display the values? So this is how you construct multiple. Now if I want, this is for 3 nodes. If I want to create for 3 or 4 nodes, 5 nodes, the same logic, only n value will change starting from I is equal to 2. Clear? Understood? Now let me move on to displaying the values of the nodes. I have the output should be 10, 20 and 30. So what should I do? I should not make use of the head pointer because head will only point to the first node. To have reference of the first node, I need not navigate my head pointer, right? Which is the other pointer, temp. Now where is temp pointing? It is pointing to the last node. In order to print the value, I have to move the temp pointer to the first node, correct? Only then I can access temp pointing to data as 10, then temp pointing to data 20 and then 30. So what will I do? What is the next line here in order to display the continuation? Temp is equal to head. Now what is head? 1000. Now temp value becomes 1000. From here, temp will again point to the first node. Okay, then the continuation here. What do I do? While I check while temp not equal to null. Why? When my temp pointing to link is equal to null. When temp value is equal to null, in such case, there are no further nodes, right? There are no further nodes. So I just take temp not equal to null. It enters. Okay. Printf %d temp pointing to data. Temp is not equal to null. It is 1000, right? Temp is equal to 1000. Fine, because temp is equal to head. Temp is equal to 1000. It is not equal to null. So it enters temp pointing to data. What it is 10 pointing to data. So the output will be first. It will print 10. Then I have to move to the next node. So what should I do? I'll just write temp is equal to temp pointing to link, right? Temp equal to temp pointing to link. What is temp pointing to link? 2000. Now temp value has been changed to 2000. Okay, now it's coming here. Again, it will go check what is temp value. 2000. Is 2000 not equal to null? Yes, true. It enters temp pointing to data. What is temp pointing to data? It is 20. So the output will be 20. Okay, again it moves. Temp is equal to temp pointing to link. What is link? 3000. Right? Now again temp will move here. Temp comes here. Temp finally comes here. Now what is temp value? It is 3000, right? Now it will come here. Since it is not equal to null, it will print the value 30. Temp pointing to data is 30 here. Then again temp is equal to temp pointing to link. What is temp pointing to link? It is null. So when temp is equal to null, it will come out. Finally close the main function. So this is how we create a singly linked list and then display the contents of the list. I hope the video was very clear. Thank you.